This is SpaceTime, Series 24, Episode 96. Coming up on SpaceTime, could red dwarfs be less harmful to exoplanets than previously thought? It turns out that Russian space station mishap was much worse than previously reported. And Rocket Lab successfully launches a new mission for the United States Space Force. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests planets orbiting around red dwarf stars may be more habitable than previously thought. Planets orbiting around red dwarfs should be ideal places to search for life. After all, red dwarfs are the most common stars in the universe, making up at least 80% of all stars. And they have extreme longevity, living for trillions of years, far longer than the 13.8 billion year age of our universe. That provides plenty of time for life to develop on any planets orbiting a red dwarf host star in its habitable zone, the area around a star where liquid water, essential for life as we know it, could exist on a planet's surface. And red dwarf stars' low mass and limited brightness means it's also easy to detect planets orbiting the habitable zones around these stars. Observations using the European Southern Observatory's HARP spectrograph on the 3.6-metre La Silla telescope in Chile suggest at least 40% of all red dwarfs have Earth or super-Earth-sized rocky planets orbiting within their habitable zones. But there is a big problem with red dwarfs. Their low stellar flux means any habitable zone would be extremely narrow. And because the planet would need to be extremely close to its host star, it would likely also be tidally locked, resulting in extreme temperature differences created by one side permanently facing the star and the other side in perpetual darkness. But the biggest problem by far is that red dwarfs frequently generate intense stellar flares, far more than stars like our Sun. Stellar flares are magnetic explosions on stars that expel intense electromagnetic radiation into space. Those coming from our Sun are called solar flares, and they cause space weather, which can damage spacecraft, affect radio communications and navigation systems, even cause power blackouts on the Earth's surface. But the Sun's flares are fairly small. Those coming from red dwarfs are both far more violent and more numerous. Large flares are associated with emissions of energetic particles that can slam into exoplanets orbiting those stars, altering or even eroding away their atmosphere, irradiating their surfaces, and evaporating any liquid water on the surface. All this would act to limit any chance of life developing on such a world. Now, a new study reported in the monthly notices of the Royal Astronomical Society claims stellar flare activity might pose only a limited danger to planetary systems, suggesting the radiation bursts don't explode in the direction of the exoplanets. The findings are based on observations from NASA's Transiting Exoplanet Survey satellite TESS. The authors developed a method to locate where on a star's surface the flares are being launched. And they found that extremely large flares are usually launched from near the poles of red dwarf stars, rather than from near their equator, as is typically the case for our Sun. They achieved this by analysing so-called white light flares on fast-rotating red dwarf stars. These types of flares last long enough that their brightness, as observed by TESS, varies as they rotate in and out of view on the stellar surface. The team found the rotating flares by processing the light curves of more than 3,000 red dwarf stars gathered by TESS. Among these stars, they found 4 with flares large enough for their new method. They used the precise shape of each star's light curve to infer the latitude of the flaring region, and found that all 4 flares occurred above approximately 55 degrees latitude, which is much closer to the poles than spots and flares on the surface of our Sun, which usually occur below 30 degrees latitude. The findings have implications for the models of the magnetic fields of stars and for the habitability of exoplanets that orbit them. See, exoplanets orbiting in the same plane as the equator of a star, like planets of our own solar system orbiting around the ecliptic of the Sun, could therefore be largely protected from such flares, as these would be directed upwards or downwards out of the exoplanetary system. This is SpaceTime. Still to come, the Russian Mayurka space station mishap was much worse than originally reported, and Rocket Lab successfully launches a new mission for the United States Space Force. All that and more still to come on SpaceTime. Mission managers at NASA have revealed that the Russian module malfunction, which sent the International Space Station out of control for 47 minutes, spun the orbiting outpost around on its axis 1.5 times, affecting communications and power collection. It means the original estimates that the space station was flung 45 degrees out of alignment have now been revised, with a final number being a 540-degree spin. The Russian Federal Space Agency Roscosmos has blamed software issues for the sudden thruster ignition aboard the new Nauka multi-purpose laboratory module, which pushed the space station out of orbital alignment. It seems that software problem caused Nauka to try and undock and move away from the space station, a situation which, had it succeeded in ripping off its docking clamps, would have been disastrous. The crew aboard the space station only knew what was happening when alarms started sounding, and they saw the Earth and stars appearing to move away from where they should be. Mission managers in Moscow initially used thrusters on the adjacent Zvezda service module to try and stabilize the orbiting outpost, but that only led to a tug-of-war between the two modules counteracting each other and putting further stress on the docking clamps. Eventually, the thrusters on the docked Progress cargo ship were also fired up by Moscow to provide the additional thrust needed to bring the space station back under control until Nauka's thrusters finally ran out of propellant. The 20-ton, 13-metre-long Nauka had launched aboard a Russian Proton-M rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan 8 days earlier, docking onto the Earth-facing port of the Zvezda service module just 3 hours before the thruster malfunction. It's now been revealed there were problems with Nauka shortly after Proton orbit insertion, just as Nauka began deploying its solar arrays and navigational antennas shortly after stage separation. The problems included the inability by mission managers in Moscow to confirm that an antenna and docking target deployed as expected, and there were also issues with infrared sensors and the module's thrusters, even before it reached the space station. It would appear the Nauka module was never fit to launch into space in the first place. But after 26 years of construction and countless delays, it seems Russian mission managers were prepared to take the risk. Of course, they weren't aboard the space station, were they? This is SpaceTime. Still to come, Rocket Lab successfully launches a payload for the US Space Force, and China's busy launch schedule continues with the deployment of a new military communications satellite. All that and more still to come on SpaceTime. Rocket Lab has successfully launched a new mission aboard an Electron rocket for the United States Space Force. The flight was the first since the rocket failure 2 months ago. The mission from the company's Launch Complex 1 on New Zealand's Mahia Peninsula placed the experimental monolith satellite into a 600-kilometre high low Earth orbit.
Vehicles on internal power.
LOX load complete, system in recirculation. Anti-geysering disabled.
Stage 1 and Stage 2 are pressed for flight.
High flow engine purge is enabled. Deluge is activated.
10, 9, 8, 7, 6, 5, 4, 3, 2, lift off.
We are off the pad and on our way to space once again with successful liftoff from Rocket Lab Launch Complex 1. Right now, Electron is travelling at over 500 kilometres an hour and is passing 3 kilometres in altitude. Very soon, Electron will approach max Q, or maximum dynamic pressure, that moment when forces are at their greatest on the launch vehicle. Let's listen in for the call from Mission Control that Electron has passed that phase.
Vehicle is supersonic. Approaching max Q. Cleared max Q.
There's the call out. Electron has successfully passed through max Q. Propulsion is continuing nominally on the first stage as we approach the next event in Electron's ascent.
Altitude is 30 kilometers. Speed is 1.3 kilometers per second.
AOS Chatham Station.
First up, the 9 Rutherford
Sabre
engines will
holding
throttle
nominal,
down
standby
before
for MECO
shutting off
approximately
completely,
30 seconds.
otherwise known as main engine cutoff or MECO. Shortly afterward, we'll see separation of the first and second stages, followed quickly by ignition of the single Rutherford engine on Electron's second stage.
MECO confirmed.
We've had a successful MECO stage separation and second stage engine ignition. Next, we'll be coming up on fairing separation. This is when the two halves of Electron's fairing separate and fall away in preparation for payload deployment. And there it is, fairing has separated, clearing the way for payload deployment coming up in approximately 50 minutes from now. Meanwhile, stage 2 is continuing well to orbit, carrying the kick stage and the monolith satellite. And we are looking at a healthy stage 2 burn, 4 minutes and 5 seconds into the mission. At an altitude of about 10,000 plus and a velocity of over 165, Electron continues nominally. We're in the middle of our stage 2 burn, taking us to an elliptical orbit, after which the kick stage will separate in preparation for payload deployment. All systems continue to look nominal. Ahead of kick stage separation is the battery hot swap. On our way to orbit, we are traveling at a speed of over 13,000 kilometers with an altitude of over 200. Now for one of the events of the launch events unique to Electron, the battery Jettison. The fuel pumps in Electron's Rutherford engines are powered by batteries, but once those batteries are depleted, it's just added weight that we don't need to carry all the way to orbit. So we swap out the depleted batteries for a fresh new one to keep Electron's second stage going all the way. We call this maneuver battery hot swap, and it's coming up next.
Confirmed.
And there it goes, falling away, meaning that battery hot swap has been completed.
HVB battery discharged holding nominal.
Electron's second stage is now approaching SECO, or second engine cutoff. Much like main engine cutoff, the stage 2 Rutherford will throttle down before the kick stage separates ahead of payload deployment. We are now 8 minutes and 13 seconds into flight, and everything is looking great for payload deployment in approximately 45 minutes.
Stage 2 shutdown.
Stage 3 separation confirmed.
And that confirms Electron's second stage engine has shut down and the kick stage and second stage have separated. So the kick stage will now enter what we call a coasting phase while it's in an elliptical orbit before its Curie engine ignites to circularize the orbit ahead of payload deployment.
The mission, named It's a Little Chilly Up Here, was designed to see how a deployable sensor, which makes up a significant fraction of the spacecraft's total mass, would affect the satellite's dynamic properties and its ability to maintain spacecraft attitude control. The experiment could see the future use of smaller satellite buses deploying larger sensor payloads. It was Rocket Lab's 4th launch this year and the 21st flight of the Electron rocket. The mission was originally meant to fly from Rocket Lab's new launch complex at NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast. Construction of the Wallops Island pad was completed in December 2019, but software coding issues have delayed NASA's certification of the autonomous flight termination system needed for range safety, forcing the flight to be moved to New Zealand. It was also the first Rocket Lab mission since May the 15th, when an Electron rocket carrying 2 Black Sky Earth imaging satellites failed to reach orbit. That Electron and its payloads began tumbling out of control just after the Stage 2 engine ignited. Investigations by Rocket Lab, overseen by the US Federal Aviation Administration, determined that a faulty igniter system on the Electron rocket's second stage Rutherford engine was the cause of the failure. The issue triggered a corruption of signals within the engine's computer, causing the rocket's thruster vector control to deviate outside normal parameters, shutting down the engine. Rocket Lab says new redundancies have now been included to prevent a similar igniter problem occurring in the future. This is SpaceTime. Still to come, China's busy launch schedule continues with 4 rocket launches in a week, and later in the science report, concerning evidence that the Gulf Stream is losing its stability. All that and more still to come on SpaceTime. China has launched a new military communications satellite, its 4th launch in a week. The mission aboard a Long March 3B rocket delivered the Zhaoqing or ChinaSat-2E spacecraft into geostationary orbit. The flight was launched from the Xichang Satellite Launch Center in southwestern China. It marked the 28th orbital launch this year and the 9th since July the 1st. Earlier in the week, a Long March 6 rocket was launched from the Taiyuan Satellite Launch Center in northern China's Jiangxi province, carrying the KL Beta A and B technology demonstration satellites. They were placed into a 900-kilometer high orbit to test laser communications and electric thruster technologies. Meanwhile, the iSpace Hyperbola 1 rocket failed during its test flight from the Zhuquan Satellite Launch Center in northwestern China's Gansu province. The 24-meter tall solid-fueled rocket was attempting to carry a classified 300-kilogram payload into a 500-kilometer high orbit. It was iSpace's second launch failure out of 3 orbital attempts. The busy week started with the launch of a Long March 2D rocket, also from Zhuquan. It was carrying a new Earth observation spy satellite for the Chinese military. The launch of the Tianhu 104 had been delayed since July the 15th due to technical issues. Beijing claims the spacecraft will conduct land and resource surveys, update global mapping, and undertake scientific research. In reality, it's a stereotopographic three-dimensional mapping satellite operated by the People's Liberation Army and equipped with both a survey camera and a CCD camera with a ground resolution of 5 meters. The spacecraft was successfully placed into a 504-kilometer high sun-synchronous orbit. Since 2016, Beijing's launched some 84 Yagang spy satellites and more than 136 Earth observation satellites designed to provide near-continuous high-resolution monitoring of areas of interest to China. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that one of the planet's key circulation systems, the Atlantic Meridianal Overturning circulation system, which includes the Gulf Stream, has now been losing stability for around a century. The findings, reported in the journal Nature Climate Change, warn that a potential collapse of the circulation, which influences weather systems worldwide, could have severe consequences. Previous studies have already shown that the system is currently at its weakest in more than 1,000 years. The new findings support the assessment that this decline is not just a fluctuation in linear response to increasing temperatures, but likely means the approaching of a critical threshold beyond which the circulation system could collapse. The factors contributing to this decline include freshwater inflow from the melting of the Greenland ice sheet, melting sea ice, increasing precipitation, and river runoff. See, the problem is fresh water is lighter than salt water and reduces the tendency for water to sink from the surface to greater depths, which is one of the main drivers of the circulation system. A new study claims the human race is now in a better position to eradicate COVID-19 than what it was to eradicate polio, but still considerably less than for eliminating smallpox. The findings, reported in the British Medical Journal, are based on a 3-point scoring system for 17 variables seen during both the eradication of polio and smallpox. These include things like the availability of a safe and effective vaccine, lifelong immunity, impact of public health measures, effective government management of infection control messaging, political and public concern about the economic and social impacts of the infection, and public acceptance of infection control measures. The study found the current pandemic to score higher than polio. The authors say the main challenges are getting the majority of people to take the vaccine and how quickly authorities can respond to the emergence of new variants. The World Health Organization says more than 8 million people have now been killed by the COVID-19 coronavirus, with over 4.4 million confirmed fatalities and more than 205 million people infected since the deadly disease was first spread from Wuhan, China. The locally extinct western barred bandicoot has been returned to the Stuart National Park after an absence of more than 100 years. The threatened species once ranged right across inland Australia, including the area now included in the Stuart National Park, but it became extinct from most areas following European settlement. Now a founding population has been reinstated thanks to a collaboration led by the University of New South Wales. Their reintroduction is seen as another major milestone in the Wild Deserts Conservation Project, which last year saw the reintroduction of bilbies and mulgaras into the park after the eradication of rabbits and introduced predators from the area by creating one of the largest feral animal-free zones in Australia. Paleontologists have identified a new species of ancient crocodile from fossils uncovered in the Patagonian mountains of southern Chile. The newly discovered species named Berksuchus melograndensis roamed Earth during the late Jurassic epoch some 148 million years ago. The discovery, published in the journal Scientific Reports, includes parts of a skull, the vertebral column, and some lower extremities. Although only 70 centimetres long, the reptile was already showing the body plan which would be adopted by modern-day crocodiles, alligators and caiman. Around the world, a growing number of governments and organisations are requiring people to show COVID vaccination certificates before entering venues or travelling. In Russia, criminals have taken advantage of this, developing a scheme where for 15,000 rubles, you can get a fake certificate saying you've received both doses of the country's homegrown Sputnik V vaccine. Tim Mendham from Australian Skeptics says it appears anti-vaxxers are the prime customers.
There's enough people who are anti-vaxxers who will do anything to sort of avoid the vaccine, but then also try and sort of fake their way through to suggest they've had it, which is a double standard, really. Sort of, I mean, you know, if you're bold enough to say you're an anti-vax, but you're too scared to actually say it out loud, it's a strange thing. This is Russia, but it's not only Russia, it's a whole range of different places. Of course, a lot of countries are instituting the COVID passport thing, yeah, to show that you've had the double dose.
Inevitable.
I would suggest so, yeah, and especially as countries try and open up and they want to make sure the people there have been vaccinated. So these are people selling fake certificates to say that they've had both jabs, and people will do anything for money, and some people will do anything to avoid, quite frankly, their social responsibilities. It's not the only thing, of course. This is happening in several countries. But I'm looking at a website right now which offers badges to say I can't wear a mask, medically exempt, it says. And fine, fair enough. Some people are exempt and they can't wear a mask for whatever reason. And some people are saying, thank you very much, this will help me sort of explain to people in the shopping centre why I'm not wearing a mask. But the fact you can buy 10,000 of these in one go implies to me either you're a social services centre which is handing out these to all people who don't need a mask, or you're distributing to anti-vaxxers and anti-COVID people.
Maybe you have a lot of
want to wear them.
faces.
Yeah, it's very sad, actually. And, you know, these are professionally produced badges on a massive scale. It's a worry that these things are around there. There will always be people who try and get their way around what they're required to do and just pretend and fake and lie to sort of keep themselves sort of unhassled in a way.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.